During long time, I managed to use SIG 433 MHz radio telemetry successfully, but I rarely succeed to make it work reliably after 600 meters. This is why I was looking for another solution. And I discovered the MLRS project from Oli on rcgroup.com that use LoRa module because it offers long range, and anymore it uses legal frequency and power in my country. Oli did really a super job. Simply, on my opinion, it's difficult for someone who was not already involved in that kind of project to understand and do it. Let me explain why. Oli made a super documentation about his project that I didn't fulfill because it's in separate GitHub repository between the documentation here and the file here. It's just so much with so many possibilities of hardware and configurations that it becomes hard for me to understand what I have to do for my specific use. And this is why this video may help you to understand what is the MLRS and what you can do with this and how to make it. You will find below this video all the links about what I'm speaking about. So what is the MLRS? The MLRS purpose is to transmit loud and far the stick position of your RC transmitter and the Mavlink telemetry when usually it's out of range. Unfortunately for me, my RC transmitter is not compatible. However, I'm very interested by reliable Mavlink telemetry, and for this reason I won't speak up here about the RC transmitter, but if you intend to use it for RC transmitter, it will probably anyway help you. So when you dig in the documentation, in the setup, you will see SIG telemetry replacement. And it's exactly what I want to do. So what about the hardware choice? You will find some hardware option in the documentation, and I choose the SID Studio WIO E5. It's not the most powerful, it's also not the most cheap, but only indicated as attractive to build the MLRS, and honestly I trust him. I forgot, this is a Storm32 board. I don't remember why Oli chose this instead of an ESP32, which is probably much well known, but there is probably a technical reason that I don't remember. So we will have to learn how to program this Storm32 board, which appear few more complex than an Arduino or an ESP32, for example. And to achieve this, we need a Storm Programmer interface. There is really a lot of kind, but let's do simple. The most well known is the ST-Link V2. So I didn't look furthermore, it was enough for me. So you need two boards like this. I will open. Okay, in the package you find one USB-C cable, few headers, sticker for pin probably, I don't look at this, one antenna, and the board itself, it accepts to come out. So first of all, plug in the antenna. Because you must absolutely not power on the board without the antenna, it may damage it. So as you see in the documentation, we need to perform a small modification to use this board. Mainly add a resistor and LED to know the link status. What I did here, So this is ST-Link V2 programmer, and you need to connect on both sides on 3.3 volts, ground, DIO, and CLKP. And then we are ready to flash the board. I forgot two details about our preparation. On each board, you will have to add two pins minimum on TX2 and RX2. On the receiver module, on the drone, you will have to connect the telemetry port on TX2 and RX2. And you can do this directly by soldering wires or with DuPont cable, it's up to you. And on the ground module, on the TX module, this one, you have to get a connection to your laptop or tablet. I don't know what you will use as ground station, but you will have to set up a connection. So the USB-C is only for the command line interface, and you can't use to get data from Mavlink from the receiver module. And for this, you will need, there's two possibilities, an USB to TTL converter to plug in on RX2 and TX2 and USB, or like I did with a Bluetooth HC05 module, which is, in my opinion, more convenient because you can use wirelessly and then put the TX module where you want, even if it's 5 meters away from your laptop. And you have, of course, to configure this HC05 module, and I will give you the parameter I used. So before to flash the Storm 32 board, we have to first get the programming software, and also to get the firmware file for the TX and RX module. TX is ground and RX is the receiver meaning on the model, on the drone, etc. So first we will go to st.com to get STM32Cube programmer software. You must choose the right version for you if you have Mac, Linux, or Windows 32 or Windows 68. I got this one. I already download, so I won't perform a second time. Then you have to go to the GitHub repository of the MLRS, go to firmware pre-release, and then you will see that it's sorted by RX and then TX. So first we can go to RX and find the board we need, so this one, WIOE5 Mini. Print the file and download. I already did it, sorry. So I won't do second time. It's the same thing for TX module. So TX, there is two different files. One for the one when you use the Scotty diode, and one when you don't use. I will not use, so I choose this one, and I also download. And after this, you can start STM32Cube programmer if it didn't just after the installation itself. So you can notice that I already prepared the TX module, the ground module. It's already ready. For the second one, you have to do exactly the same thing than for the first. So you have to plug in ground, 3.3 volt, DIO and SCK pin, and to do the same thing on the ST-Link programmer. So then you just have to plug in the ST-Link V2. You must press the boot button, and while you press it, you press reset button, and it's ready. On STM32Cube programmer, you hit connect, and you get an error message. Error, data read failed. So you can only press OK, it's what you do. Go to the OB tab, go to readout protection, it's probably in BB, and you have to select AA, and then apply it. Option byte successfully programmed. Okay. You go to the erasing and programming tag. Here you see that it was already selected the TX module, and now I select, of course, RX module because it's my RX module. Verify programming, if we want, probably, and start programming. Download verified successfully, file download complete. So okay, everything is done. Now you can power cycle the board, and let's see what happens. And you see that the LED are blinking, so everything is ready. And now we have to check and to adjust, if necessary, the parameter on the two boards. So first you will have to power on the receiver board. So for me it's the last one that I programmed. And to plug in USB on the ground board, on the TX board. Then you will have to use CLI for command line interface. Personally I use Teraterm. So I must select serial, COM10, Silicon Labs, okay. In configuration, serial port, I know the speed is that one, data bits and stop bits, okay. Configuration of terminal, automatic, okay, maybe it will be okay. Command broadcast. So let's first try. I will copy this because we can't. Super. Not in real time and only one process. Okay. You will find in the documentation on the CLI all the control explained, all the command explained. So we can start by this PL and OK. Okay, I delete, I send again. So we see here that the rate is 19 MHz. It's exactly what I want because it's the lower rate, so it's the lowest data rate, but it's also the most reliable. So in the deep, the one with which you can get the better range. What we can see else? TX power is 10 milliwatt. RX power, where it is? It's here, 10 milliwatt also. And we know that this board is able to have a power of 158 milliwatt. So it's not correct, and we want to change this. So parameter P TX underscore power is 4. I send. So TX power was set here to 158 milliwatt. parameter 4. Okay. I do the same for RX power. It's set. And now, what it is written? pstore stores the new parameter setting in the TX module and if connected also to the receiver. And of course it's connected because we switch on the receiver first before we power on the TX board. So it's connected. So I can write this. So pstore, okay. And I set parameter stored. So if I understand well, everything is ready, the rate is good, the power is good. We just have to connect on the road. And now we will have to set up the serial parameters of the flight controller. So to access this parameter, you will have to connect by USB cable to your flight controller. Find the correct COM port here and hit connect. So you will have a parameter download like I have here. And when it's finished, okay, leave me quiet. You go to the config tab and go to full parameter list. So my MLRS RX module is connected on the TLM1 port of the flight controller, and the name of it on the parameter list is serial 1. So in the search I write serial 1. Okay. So the port speed must be this one. So here, if it don't correspond, you write 38. 38 is for the 19 Hz mode that I use. On serial options, you must have 4096, which correspond to in-your stream rate. So same as here, if it don't correspond, you change the value. Serial protocol. In the MLRS documentation, it is written to use Mavlink 2, so here you must have the value number 2. When you change the value, it gets highlighted in green. I personally use Mavlink 1 because in Mavlink 2 I get a lot of during the downloading of the parameter already got param, and downloading last, I don't know, 10 minutes, and with my Mavlink 1 it's only 1. I don't know why I have this problem, but you should use Mavlink 2. So when you did all the change that was necessary, you press the right parameter button. Are you sure? Yes. Parameter successfully saved. You hit OK. So it's perfect. And now we are ready, and you can disconnect and restart your flight control. Then you will have to try to connect via the TX module. So you power on the TX module, and if you use a HC05 Bluetooth module like I did, you must of course add a new Bluetooth peripheral. Add Bluetooth peripheral, Bluetooth type. You will find the name that you insert during the configuration of your HC05 module. Here you select, it will ask you the pin code that you also insert during the configuration of the HC05 module, and it will be ready. Then you will have to go to advanced Bluetooth parameter, go to COM port. So MLRS ground module is the name I insert during the configuration of my HC05, and you see that there is SPPDEV, and you must memorize this COM14 for me. You must memorize the COM number. Go back in Mission Planner, and here you see that it's what I already use, in fact, because my configuration was already done, so I didn't have to come back to USB cable again. And you can hit connect. And when it starts to download the parameters, that means everything is okay. It must last in 19 mode approximately 1 minute. If you reach this, that means everything is set up and you are ready to fly with the MLAs.